It's just a 30 barrel or approximately 1,000 gallons tank that has jackets on the side of it, and it's insulated. In the jackets we run steam to heat. This large square container here is our grist hopper. We crack the grain, we get the grain in whole kernels, and then we crack it and it gets augered into this, and it sits in here for the brew process. So this is our mash lauter time. It's a combined vessel that we perform our mash in, which is the conversion of the starch and grain to sugars, and the lauter process, which is a separation of what we call the wort from grain. When we go to start the mash, we just open this knife gate and run it through this piece here, which is our hydrator, and it just serves as a way to mix the grain with water as it's falling in to start the mash process. That's also a precise control point for the mash temperature, and we do that with measuring the total amount of water, the speed that the water is coming in with the totalizer here, and then we have this mixing valve where we take cold city water and we regulate this valve to hit a certain temperature, which is measured up here, because we want to hit this water temperature within a degree or so to make sure we hit our mash temp within about a degree. And that's all automatic and controlled by our PLC controls. So the grain sits in here on top of the false bottom. We use the rakes to kind of mix everything together and then create some channels for water to flow through towards the end of the mash. You put water in here at a very precise temperature. You let it sit for about an hour, and then you start the separation process. It's just a giant kettle that we can boil things in, and it has jackets on the side and insulation. One key part of it is this stack that comes out the top. There's a ring in there to catch any condensate. So when we boil, one of the things we want to do is drive off dimethyl sulfide. Very, very similar vessel. There's a couple key differences here. There's no jackets because we're not doing any boiling on this. It's just insulated. There's a tangential input here, right where your foot is, straight down.
Okay.
That causes the wort to come in at a 90-degree angle and causes it to swirl around in the tank. And that swirling action is important because that forces all the solids to the center. And then we pull off on that little hole there on the side. And that allows us to take the clear, separated wort off the site of fermentation. We pump it into one of these tanks, or fermenters, also I think what you guys call a reactor. It's got two jackets, it's insulated, and it's cooled with glycol. We add our yeast. We also add oxygen during that transfer process. Yeast need oxygen to help their cell walls when they decay. Sometimes we add yeast nutrient. It depends on the beer, and it depends on the age of the yeast. Transferring here, we add yeast, close it up. As you can see right now, we have active fermentation going. The yeast are currently in suspension and creating ethanol and CO2 among many other compounds. And during that, we're monitoring the temperature of the tank and adding glycol or running glycol through the jackets to cool it as needed to keep the fermentation temperature exactly where we want it. These fermenters, we have a cone bottom such that we can collect the yeast at the end of fermentation. It all sits down at the bottom. And we dump off any proteins or anything that has settled out during that process. Geometry is a little different. It has these straight sides. It helps facilitate dropping out of any suspended particles. It also helps with carbonation. So at this point, we actually add CO2 to get to the volumes of CO2 that we want. We've chilled it at this point too, down to about 30 degrees Fahrenheit. Also, during this transfer to this tank, we'll add fining agents, which are just particles that are positively charged or negatively charged that will bond with whatever's in suspension and help just drive it to the bottom of the tank. At the end of this process, it'll be very clear. At this point, head pressure and temperature are very important. But once we're in here and we're carbonated, we're going to have a head pressure of like 9 to 10 psi at 30 to 32 degrees. And at that point, you have to maintain that through the packaging process.